chapter 9. This should be faster. Chapter 9 is all about solubility, dissolving one thing in another. So, metals. You can have a solution of metals where one metal is dissolved in another. When metals are dissolved in each other, they're called alloys. All other things that we're going to talk about are liquids dissolving, either liquids, gases, or solids. So if we have a liquid, and at our level of chemistry, it's mostly water. You get to organic chemistry, it'll be things like acetone and different organic solvents. The thing that you're dissolving things into is the solvent. The thing you pour in is the solute. And the thing that you make all together is called the solution. Okay? This will definitely be on your test. I draw this, I feel like I've drawn this 100 times in my life. So you'll need to be able to label this. Just a minute. So, ionic compounds dissolve by breaking apart into their ions. Once again, that's just, let's say it's calcium carbonate. It will break apart into a calcium ion and a carbonate ion. Is CO3 2 plus or 1 or 2 minus?
Yeah.
2 minus, that's what it is. Okay. So it'll break apart into its ions. When an ionic compound breaks apart in an aqueous environment, these become electrolytes. Remember that term? So this is a cat ion, because if you like cats, that's a positive thing. And this is the anion. And these are capable of carrying an electric charge. So in solution, this solution will be able to conduct electricity. If you have an ionic compound dissolved in water, it conducts electricity. Okay? So if you dissolve, excuse me. So this is for an ionic compound. If you dissolve a polar covalent compound, like sugar, this will dissolve because it's polar, but it's not going to be able to carry electricity because the sugar is a big molecule with a positive side and a negative side. They are delta positive and delta negative. They're partial positives and negatives. And it's not breaking apart completely into a positive and negative. It's still attached. So it's like a big old molecule with a positive and negative side. So it will dissolve in a polar solvent like water, but it won't be able to carry electricity. Sugar water does not conduct electricity. So I, number of ions in solution would just be equal to 1 with sugar. Whereas here we've got 2 ions, I would be equal to 2. So if you're looking at freezing point depression or boiling point elevation, you're going to get more with an ionic compound than you will with a polar covalent compound. How can we increase the solubility of a solid? So for a solid, you increase the solubility by heating it. How do you increase the solubility of the gas? By cooling the liquid and by increasing pressure. Okay? And if you think about it, it makes sense. To increase the solubility of a solid, if you heat it, you're adding more energy to it, increasing the motion of that solid. For gas, you want to decrease the amount that's escaping, so you want to cool it down and give it less energy so that it will stay in solution. Increasing the pressure, you can just think of it as you're pushing the gas down into the liquid. Now sometimes we do double displacement reactions. Double displacement, again, is like a wife swap. So you've got XY and AB. You just like swap their partners, right? XB and YA. This would be a double displacement reaction. And sometimes These two are perfectly soluble, and this one might be soluble in water, but this one's not quite as soluble. And it's going to form a solid. We call that a precipitate. Precipitate. So this can be a noun or a verb. The precipitate, it's pronounced precipitate when it's a noun, precipitate when it's a verb. So this YA will precipitate out of solution, forming a precipitate, which we abbreviate with PPT. And there's a lot of questions about that in your test and in your review. If you do the Chapter 9 review, you should be very well prepared for the test. Let's see, concentration. I'm almost done. So we measure concentration in two different ways. Molarity with big M and molality with little m. Okay, molarity with the big M is moles of solute per liters of solvent. It's in liters, so make sure you change, whenever you have milliliters, change it to liters when you're calculating molarity. And then molality, little m, is moles of solute per kilograms of solvent. And again, this is in kilograms. So you'll often have your weight in grams, you're going to have to convert to kilograms. And I don't have time to do the review questions, but call me, text me with any questions. So we have to calculate, we mostly use molarity, big M, except for when we're calculating freezing point depression, negative I, remember I is the number of ions, times Kf, which will be given, times the molality, this one. And then boiling point elevation is the number of ions, times Kb, times the molality, which will be given. Okay, so I don't have time to do questions. Thanks to this guy. So my co-host and I are going to say goodbye, and